Mr. Chairman, ladies and gentlemen, in the first place, I'm very grateful that I have the opportunity to give this presentation today here. My topic is Internet of Farming, and I'm going to present two applications in which the digitalization has been utilized. The first one is related and linked into milk production process, and the second one to fish production. Dairy cows are very smart animals because they can convert roughage, that is coarse feeds, to milk. Coarse materials like hay or grass silage, which cannot be consumed by human beings directly, but when the cows convert them to valuable protein, then it's okay. But there is a problem in this business at the moment because the profitability has declined during the last couple of years. Reasons for this decline, there are many, but two main reasons are the trade ban between Russia and EU, and the other one is the abolishment of milk quota system a couple of years ago. Milking robots are very widely used. At the moment, there are close to 1,000 robotic milking system or milking robots on modern dairy farms, and close to 30% of milk produced in Finland is produced with milking robots. And it has been estimated that within 5 years, the amount of milk milked with milking robots is 50 to 60%. And these milking robots, they collect a massive amount of data on a daily basis. And that data on daily basis is utilized by the farmers who control the milking and their management. However, lots of the data is not completely utilized. And you could say that part of the data is wasted. And therefore, we in Raisio Agro, we have recognized this and created and developed a way to utilize the excessive or large amount of data. This picture illustrates the milk production process. There are many stakeholders in the process, and even many more than illustrated in this picture, but the key players are here. The farmer himself or herself is the key player. He makes the feed, usually these grass silage in Finnish conditions. He makes the feeding plan, buys the feed, do the feeding, and then controls the milking robot. Dairy plant is also deeply involved in this process. They analyze the grass silage, they collect the milk and make milk analysis. And on the bottom there is a research agronomist who in our system puts the data together or controls the system that everything goes well. She puts the data together and delivers a report to an individual farm every week if so needed. And actually it's a question of digital network with the feedback to the farm. So This is a very simplified picture, but anyhow it illustrates how it works. And we have named this system tuotostutka, which is rough translation would be production radar. So it's a milk production data analyzing service. And here in these graphs, some examples of the report which is delivered to the farmers. You can see that, for example, amount of milk, fat percentage, protein percentage are measured, and many other parameters. At the moment, this real-time interaction takes place with close to 200 dairy farms, and this number is increasing all the time. And one possibility in this case is that this data it forms a big data, really big data. I'm sure that there is scope for artificial intelligence and data mining when this data is further utilized. And this is, of course, a challenge for ourselves and for any of you, how to proceed in that area. Then let's move to the fish production. Rainbow trout is raised in cages like this, and we have developed kasvuluotain, an application. Rough translation would be growth radar, and an application for fish farmers. And in this application, in the first place, we establish the fish groups, and then in this system, feeding recommendations are given in a smart way based on estimated biomass and temperature. And then in the long run, we are going to build a connection to our optimization of the production and warehouse system and logistics as well. And in the next couple of slides, I'll show you how it looks like, how the reports and how the interface looks like. And here you can see some of the figures, when the user uses the application, how it looks like. One very important element is the temperature, because the feed allowance is based on actual temperature. And temperature is measured online in 5 different depths in the water. And then the amount of feed fed daily is based on that figure. Of course, the estimated biomass as well. And here you can see some graphs how it looks like. The upper one is feed amount per day, and the low one is the temperature. And then you see that there are 2 curves. The one is the, let's say, the recommended value, and the second one is the one which has really taken place. And this slide, you see the estimated biomass development. These 2 examples are, let's say, built on a real customer experience and customer need. We have very carefully studied the real needs of customers, how the application should look like, what kind of data they need. And we have been lucky to work together with a company called Leadin, who has specialized on customer experience studies. And that is something which we are certainly looking also in the future. And let's say, I mentioned already the data mining, artificial intelligence. They are areas where we see lots of possibilities in the future. And as a summary, I would like to say that we are extremely happy that we have started this Internet of Farming project, thanks to Tekes for support in this project. I have a feeling that we are just in the beginning of this journey, and there will be many other applications in the future. So, thank you for your attention.